After the instances run correctly, you can see here on the web application that I'm seeing more events being generated. So there's a total of 3 events per second being generated, and you can see here that one of them comes from micro event generator 1, the other comes from instance gen B, and the ID of the instance on Amazon Web Services, and another one from the separate instance. So you can track which nodes are generating events in the cluster, which is quite neat. Now, how are these instances being auto-provisioned when they're starting? That is simple. So here, let's kill this instance, and it will automatically deregister itself from the cluster. And let me show you here that I have configured a specific script called micro event generator. And this script is being used in order to start the Payara Micro instance when the machine is starting. So of special interest, you can see here that I'm setting up the name of the instances using these 2 variables, AWS name and AWS instance ID, and I'm logging the output of the instance to a file in order to allow this to work as a service. So how do I set up these variables? I'm using this specific script that will run at the startup, that will use the Amazon Web Services public API in order to extract the region first that I'm running, and then get the instance ID, and then from that instance ID of the current instance that is running, I will get the key value pairs for the name tag on the machine, and I will export those values, and those values will be available to the other script that I showed you previously. So lastly, I'm using this service definition in order to configure my service as startup. So what I'm doing is running the first script that I showed you that will start the event generator Payara Micro instance, and I'm tying that to the exec command of the systemctl service definition. And that's it. Whenever an instance that it's created automatically by the launch template here and the Amazon Web Services infrastructure, then it will automatically use that script and start a new Payara Micro instance. And since the micro instance know how to talk to the cluster by locating the cluster dash node, then it will automatically join the cluster. So here you're seeing, since I killed that Payara Micro instance that was running the first generator, I don't have 2 generators, but I can quickly create 2 new generators using my launch template, and in this occasion I will use the subnet C, and here on the name I'll use gen C as a suffix for them, and that's it. All instances that will automatically be created by the Amazon Web Services launch template will find the cluster dash node, join the cluster, and all of that will be neatly reported on the data grid status, which I can see here on the log output for the micro instance for the web application. So I can see here that there are 1, 2, 3, 4, 5, 6 instances on the cluster, 1 for my master node, 1 for my web application, and 4 instances that are generating events. If I go here to my web application, I can see here that there are 4 generated events every second, and I can track which instance generated them. And it's simple and easy enough to understand. So in summary, elastic deployments are easy to implement, and the products of the Payara platform allow you to deploy applications on the cloud with minimal effort and minimal configuration, as I showed you using Amazon Web Services. I also encourage you to check other demos and cloud topics on our official YouTube channel, and to read more about the platform's distributable strategies on our official blog as well. Search for the clustering topic if you're interested in other scenarios or other cloud providers, for example. So thank you. I hope that you enjoyed this demo. See you. Bye.